Today, we proceed further to observe actual physical appearance of stationary waves. The essential to observe formation of stationary waves is presence of propagating medium which is bounded. We consider both types of formation of stationary waves, transverse stationary waves as well as longitudinal stationary waves. We can observe transverse stationary waves on the medium like straight string, in which transverse progressive waves can be generated. We can also observe longitudinal stationary waves in the medium like air column, which should be bounded in the pipe. The pipe may be open at both ends or may be closed at one and open at the other end. So today we will study actual physical appearance of stationary waves of both types. The media in which the stationary waves are formed initially have to set in vibrations. For example, here I have one straight string. Look over there. This is the straight string. Are you observing? Otherwise, I will take it. This is the string. Are you getting? Its one end is tied to this vibrating rod and its another end is passed over this pulley. This is the rigid support and its free end is supported with this light pan. You are getting it, I hope. So this entire apparatus I have arranged for you. A straight string between two rigid supports. This is one end and this is the other end. Between these two, the string is made stretched. So what we have to do initially to observe formation of transverse stationary waves over this, we have to set it in vibration. So what I will do, I will set this end of string which is attached to this fork. एक fork है उसमें ये attach किया है. I will vibrate these forks. These vibrations of the fork will get transmitted over the length of the string. At the other end of the string, being a rigid support, this will get reflected back and incident wave and reflected wave will interfere, will superimpose and you get transverse type of stationary waves over here. Here is a pipe. Initially, it is open at both ends. ये एक end है, ये एक end है. ये pipe में जो air column है, it is a bounded medium. And in the air column, longitudinal type of progressive wave can pass. But to produce longitudinal type of progressive wave, what we will do? We will take a tuning fork. We will hammer it and will set in oscillation. Such oscillatory tuning fork we will hold at one of the open ends of the tube. And these longitudinal waves will pass through this air column. At the other end, they will get reflected back because it is bounded. तो ऐसे एयर कॉलम में लॉन्गिट्यूडिनल प्रोग्रेसिव वेव पास हो सकते हैं एंड फ्रॉम द बाउंड्री Satisfying boundary condition, these longitudinal progressive waves will get reflected back. Within this bounded air column in the pipe, two waves exact identical along same direction in opposite direction along same line superimposed, and the production of longitudinal stationary waves will be observed in this pipe. ये जो pipe है ना, वो जो bound है, if I keep this pipe exactly vertical with one end closed, means what? I will take a jar. Look at the apparatus. I am trying my level best to show you the things. So this is a jar. It is filled up to this level with water. If I dip partially this pipe inside the water, then one of its end will get blocked and the other end will remain open. So you will have an air column which is bounded at one end and closed at one end. This is air column open at both ends. But you can make air column closed at one end by dipping it in such jar. ऐसे air columns हम बना सकते हैं. So to observe transverse stationary waves, the medium we prefer is stretched string. But this string should be bounded between two rigid supports. हाँ, जैसे मैंने आपको दिखाया, देखती हूँ पूरा वीडियो देखा जाएगा क्या? This is a tuning fork. One end of the string is tied to prong of tuning fork. Then it is passed over the pulley. ये पुली है, उसके ऊपर passed है. So this is also a rigid support. And you will get a definite length of stretch string between two rigid ends. ऐसे हम लोगों को मिल जाता है. And over such we can observe the appearance of stationary waves. Now what will I do? Initially the medium will be at rest in its equilibrium. If you want to observe appearance physically, actually, the stationary waves over the string, initially, that given bounded medium should be set in vibration. So you have to disturb it from its equilibrium position. And then the force we are using to disturb it should be removed off. बाद में वो फोर्स हम लोगों को निकालना है. And you have to release it from disturbed position. So it will set in vibration. Observe the motion of the string in the video. I am trying. देखते हैं आप लोगों को कुछ समझ आता है या नहीं. ट्राई कर रही हूं मैं, दूसरा कोई हेल्प करने के लिए है नहीं, तो थोड़ा दिक्कत आ रही है. देखती हूँ क्या होता है. If I could manage, it is well and good. Otherwise, I will show you that video. This string here, आप लोगों को दिखाई दे रहा है क्या? देखो मैं बंद कर देती हूँ वाइब्रेशंस ऑफ फोर. अ प्लेन स्ट्रिंग यू कैन ऑब्जर्व दिस प्लेन स्ट्रिंग. ये जो प्लेन स्ट्रिंग है ना, ये वाला, वो आपको दिखाई दे रहा है. इफ आई सेट द फोर्क इन वाइब्रेशंस, अभी क्या हो रहा है देखो हल उसका. आप लोगों को क्या दिखाई दे रहा है? कुछ दिखाई दे रहा है क्या? बताओ मुझे, बताओ दिखाई दे रहा है क्या? हाँ, व्हाट आर यू ऑब्जर्विंग ओवर द लेंथ ऑफ द स्ट्रिंग? ओवर द लेंथ ऑफ द स्ट्रिंग क्या दिखाई दे रहा है? आप बोलो. कुछ वाइब्रेशंस हो रहे हैं ना, वाइब्रेशन है और लूप्स दिखाई दे रहे हैं क्या, देखो, आर यू गेटिंग द लूप्स, कैन यू सी द लूप्स, ये ऐसा, ये एक लूप है, देखो ये ये बाजू, हाँ, आर यू गेटिंग, डेफिनेटली, सो दिस इज वन लूप, हियर इज वन लूप, ये दिखता है ना, ये देखो पूरा एक लूप है, ये वाला, दिस इज वन लूप, दिस इज वन लूप, सो नंबर ऑफ लूप्स, देखती हूं मैं दूसरे एंगल से, आपको ज्यादा अच्छा दिखाई दिया तो, देखो लूप दिखता है क्या, ये देखो बीच में बड़ा लूप दिखाई दे रहा है, दिखता है, हाँ, आर यू गेटिंग, नो, ओके, आई विल क्लोज, आई विल मेक इट प्लेन, अभी स्क्रीन दिख रहा है, अभी मैं चालू करती हूँ वाइब्रेशंस, तो स्ट्रिंग विल स्टार्ट वाइब्रेटिंग एंड इंसिडेंट रेस and reflected rays will superimpose and you will observe the appearance of loop, दिख रहा है, ये लूप है, एक लूप है, here is node, at the end here is node and in between you are observing the loop, अभी देखो ज्यादा अच्छा दिख रहा है क्या, हाँ, इधर एक लूप खत्म हो जाता है, ये बाजू, ये एक लूप है, इट एंड्स ओवर हियर, so this way we can observe the actual appearance of stationary waves, both types, अभी एयर कॉलम मैंने वाइब्रेट किया, तो भी एयर कॉलम will be set in vibration by holding vibrating tuning fork at any open end, it will get reflected back from the other boundary, the boundary may be from rigid support, that is denser medium, or boundary may be from rarer medium, बाउंड्री कौन सी भी हो सकती है लेकिन वो मीडियम बाउंडेड चाहिए, so I tried my level best to show you the physical appearance of stationary wave. I don't know to what extent you have got it, but still when you come in college physically, I will repeat it again during practicals. इसके ऊपर हम लोगों को 12th में 3 प्रैक्टिकल्स है, प्रोडक्शन ऑफ स्टेशनरी वेव्स ट्रांसवर्स टाइप 2 प्रैक्टिकल्स है, और प्रोडक्शन ऑफ लॉन्जिट्यूडिनल स्टेशनरी वेव्स उसके ऊपर एक प्रैक्टिकल है, तो जब भी हम लोग प्रैक्टिकल्स करेंगे तो ये कंसेप्ट और भी ज्यादा आप लोगों को क्लियर हो जाएगी, सो विल प्रोसीड फर्दर विथ थियोरेटिकल पार्ट of the appearance of stationary waves. So this is just demo, मैंने खाली आप लोगों को डेमो बताया, अभी हम लोग आगे चलते हैं, so what we have to discuss, we have to discuss the vibrations of bounded medium. When stationary waves are formed within the bounded medium, it starts vibrating, but boundary conditions limit the modes of vibration. This bounded medium can vibrate in any mode. अभी क्या है, suppose I have one Now we'll proceed further with the theory part. Now I will focus on the board. If I have a straight string which is of length small l bounded between two rigid support at x is equal to 0 and at x is equal to l, I will arrange this string under tension. इसमें कुछ मैं टेंशन लगाती हूँ. So effective length of bounded medium in the form of straight string is, we assume, L. Now what will happen? I will keep this string in such a way it will be in x direction parallel to horizon. Yeah. Now what happens? These boundary conditions limit the vibrations, modes of vibrations of the string. If I pluck the string at any point and if I release it, थोड़ा सा मैं पुश करती हूँ, लेती हूँ, देखो ऐसा करने का. This is stationary. I will pull it at some point and I will release. It will start oscillating. You can plug the given at any point. कौन से भी पॉइंट पे ये आप लोगों को प्लगिंग करना है और छोड़ देना है. What will happen from the point of plugging? These vibrations of the string will be carried over the string in the form of progressive wave. ये मौजूद ही जाएंगे. In all possible directions, progressive waves will start. But when they reach the rigid support, at the rigid support, amplitude will be minimum. That is 0 only. And instead of propagating further, ये disturbance है ना, rigid support के आगे नहीं जा सकता है, क्योंकि ये rigid support point always remain at rest. And rest है, इसीलिए discontinuation मिलता है. So these waves will not get propagated beyond these rigid ends. Instead, what will happen? By satisfying conditions, these waves will get reflected back. ये जो waves है ना, वो reflect back हो जाती है from this rigid support. The condition, what is the condition? The particle at rigid support should not set in vibration. The displacement of particle at these nodes should remain 0. And when displacement is 0, there should be formation of nodes. So what is boundary conditions to be satisfied? To set this stress string in vibration, nodes should be formed at both rigid supports, and this wave will get reflected back. This wave will get reflected back, and incident and its reflection will be in the same medium along same line, only in opposite direction. So on the length of the string, you will get appearance of loop. ऐसे लूप्स हम लोगों को दिखाई देते हैं. During reflection, there is phase reversal of pi radians. If boundary is from denser medium, in reflected wave and incident wave, we always get phase reversal of pi radians. Means trough gets reflected back as a crest. If crest appears, it gets reflected back as a trough. तो अभी क्या है, हम लोग ये स्ट्रिंग है ना, उसको वाइब्रेट करेंगे. Only during vibration, nodes will be at two fixed ends. You can set these string in vibrations in different ways. Suppose I plug the string at exactly center. मैं सेंटर को प्लग किया और मैंने छोड़ दिया. So point at the center will vibrate with maximum amplitude. And what is to be satisfied? Zero displacement at both rigid supports. ये जो rigid supports है ना, उसमें जीरो डिस्प्लेसमेंट चाहिए. अगर मैं सेंटर प्लग करती हूँ और छोड़ देती हूँ तो ये सेंटर पॉइंट विल वाइब्रेट विथ मैक्सिमम एम्पलीट्यूड. सो यू विल गेट फॉर्मेशन ऑफ वन एंटी नोड in between these two rigid supports, and you will get the straight string in the form of single loop. ये सिंगल लूप के हिसाब से ये सिंगल लूप ये स्ट्रिंग के ऊपर डेवलप हो जाता है. दिस इज वन ऑफ द मोड्स. इन अदर वे व्हाट यू कैन डू, यू कैन प्रिवेंट द सेंटर पॉइंट फ्रॉम वाइब्रेशंस. ये इधर हाथ रखना है, इधर भी हम लोग एक रिजिड सपोर्ट देंगे, प्रिवेंट करना है. एंड यू प्लग द पॉइंट मिडवे बिटवीन एनी हाफ द सेगमेंट. कौन से भी एक सेगमेंट के मिडवे प्लग करो तो क्या हो जाएगा, ये इधर एक एंटी नोड तैयार होगा एंड इधर भी एक एंटी नोड तैयार होगा. एंड एट द पॉइंट ऑफ सपोर्ट एट द सेंटर नो डिस्प्लेसमेंट. So we'll get 3 nodes and you will get 2 antinodes. So the stationary waves formed in the second mode will have wavelength lambda. In the first mode, they will have wavelength only lambda. You can set this string to vibrate in such a way that 3 loops will get formed. Only if they should satisfy the condition, 2 nodes at 2 fixed rigid supports. So wavelength of waves generated in this case will be different from lambda as well as lambda 1. But this way you can set this string to vibrate. And we get different natural modes of vibration. ये नेचुरली वाइब्रेट होता है, हम लोग कुछ कर नहीं रहे हैं, खाली वाइब्रेशन सेट टू डिस्टर्ब इट फ्रॉम इक्विलिब्रियम पोजीशन so that it will get set in vibration. You are giving an external force, you are disturbing it and you are removing the external force you have supplied, and then the body is set in vibration. लेकिन वाइब्रेट होते समय ये दोनों बाजू नोड्स तैयार होने चाहिए. सो एंटीनोड नंबर में भी डिफरेंट. द स्टाइल यू प्लग एंड रिलीज द स्ट्रिंग विल गिव यू दैट पर्टिकुलर मोड ऑफ वाइब्रेशन. हम लोगों को स्ट्रिंग को कहाँ प्लग करना है ये डिसाइड करना पड़ेगा. When the string vibrates with formation of one antinode and 2 nodes, it is called its simplest mode and is called fundamental mode of vibration. इसको fundamental mode of vibration बोलते हैं. You can say let the string to vibrate in any higher modes with formation of 2 loops, with formation of 3 loops, etc. depending on your initial setting vibrating conditions. आप लोग करते हैं. So this fundamental mode is also called mode of first harmonic. Only few modes, only with few frequencies, these boundary conditions let the string to vibrate. Frequency 1 Hz है और string को vibrate करो. Adjust the string so that it will vibrate with frequency of 2 Hz. ऐसा नहीं होता है. Boundary conditions limit the frequencies, that is the modes, because in different modes it is vibrating with different frequencies. अभी ये मोड में फ्रीक्वेंसी उसकी n है तो ये मोड में फ्रीक्वेंसी ऑफ वाइब्रेशन ऑफ द स्ट्रिंग, number of oscillations it completes in 1 second will be different. So this frequency n1, n2, these are permitted frequencies n, n1, n2 with which the string can vibrate. ये जो मोड्स है ना वो परमिटेड है, एंड दैट मोड्स आर परमिटेड बाय बाउंड्री कंडीशंस, बाय बाउंड्री लिमिट्स. Similarly, you can observe air column also. देखो एक जार है, उसमें मैंने वाटर फिल किया है. आई विल कीप दिस पाइप with one end dipped in water held exact vertically. तो ये end close हो जाता है और ये एक end open हो जाता है. So air column should vibrate satisfying boundary condition, and closed end there should be formation of node, and at open end there should be formation of antinode. Because when these waves get reflected back, ये इधर जाते हैं ना waves, तो इधर आते समय there is no any phase reversal. जब भी reflection occurs from rarer medium, phase reversal does not take place between these two. So compression gets reflected back as compression only, and rarefaction as rarefaction. Here longitudinal type waves है, और here crest or trough. Here compression and rarefaction. But we never think of this. ये हम लोग ध्यान नहीं देते हैं. तो ये क्या होता है? One node, one antinode. You can say the same with formation of two nodes. Suppose ऐसा एक लुक तैयार हो सकता है. We can make the same air column to vibrate in such a way you will get formation of three nodes. एक तो कंपल्सरी आएगा ही और बीच में दो आएंगे. तो ये दोनों हम लोग एयर कॉलम भी डिफरेंट मोड्स में सेट कर सकते हैं. तो ये हम लोगों को देखना है. In practicals you have to study all this. In next lecture I will go further to find the values of frequencies with which such can be vibrated, and we are interested in finding value of minimum frequency with which it can be set in oscillation. So I am closing the meet for all.